Hello, everyone, and welcome to today's webinar. Today's webinar will be given by Chris Calderon, one of our major architects for iMachining the Wizard, and the webinar will be given on the new option that we have for iMachining using insert cutters. Now, of course, there'll be time for questions at the end, so you can write down your questions. And again, this is being recorded, so if you need to listen to this afterwards, you can. We won't have any problem with that as well. And I hope you enjoy the webinar. This will not be too long of a webinar. So let's get started. Chris, I will make you the presenter.
Okay.
And you can go ahead, show us your screen, and get started.
Okay. Which screen?
And yes, we see it.
Which one do you see?
The wrong one.
Yeah. How can I
Okay,
change that?
just right.
Share another.
That's it. Okay, no, not that one.
No, it's not one. I'm trying to. Oh, change the. No. Make another attendee. Sharing.
No.
Oh, here. I think I found it.
Okay.
Monitor one. Okay, there we go. That should be it.
That's it. Now we got
Okay.
it.
Now
Go
we're
ahead.
ready. Hi, everyone. Thanks for joining our webinar about iMachining and insert cutters. Today I'm going to show you the results from our test cutting done with insert tools. I am then going to show you what development was done to support insert tools and how to use this new option in SolidCAM. Why do we want to use insert cutters? Insert cutters are available in large sizes. This is beneficial for when large volumes of material need to be removed. Solid carbide tools are expensive in large sizes. Also, the only way to renew the cutting edges of a solid carbide tool is to regrind them versus replacing the inserts on an insert tool. So what is the preferred insert tool for use with iMachining? The porcupine style. These cutters have many inserts aligned vertically. The vertically aligned inserts allow for large depths of cut. This is one of the major benefits of iMachining. It is the ability to take large step downs. Having inserts aligned vertically allow for even wear distribution due to the many edges being used at once. What is the preferred machines for use with iMachining and insert cutters? Due to the large size of insert cutters, we want to use large and strong machines. These machines do a much better job holding the tool against the stock without machine flex. That can cause vibrations. Our test cutting was done at Pilsen University. The machine used was an MCU 450 5-axis, equipped with an 18,000 RPM spindle. The tool used was an ISCAR H490 25mm diameter with 2 flutes of inserts. The machine is medium-sized and of medium strength. This is not preferred, but does represent a more common use case. Our first test cutting we wanted to do was some traditional cutting using standard pocketing toolpath on D2 tool steel. We attempted to cut at full depth. Let's watch the video. A lot of vibration started as the tool needed to transfer from one pass to another attempting full slotting. This was not going to work, so the operator needed to stop the machine. This type of cut is not possible on this machine. We were asking too much. Our second attempt with standard pocketing was to reduce the depth of cut to an achievable amount. Let's watch the video. From the video, we can tell the cutting is actually good. The problem is we were only using the bottom set of inserts. Let's watch the video from later in the cutting and see what happened. So only using the bottom set of the inserts caused excessive wear on those inserts. The edges eventually wore away and the pocket could not be finished with one set of inserts. We were able to get photos of the inserts from the standard cutting at 20 times and 120 times magnification. We can see how far the cutting edge has been worn back. It's completely gone. Now we wanted to see if iMachining could cut at full depth using small stepovers. Let's watch the video. Success, as we were able to machine the entire pocket with one set of inserts. We can see similar benefits that we see with iMachining using solid carbide tools as when using insert tools. Let's look at the tool wear on the inserts. We can see some wear on the cutting edge, but much less than the inserts used with standard cutting. We then took a similar strategy of iMachining to some P20 tool steel. Let's watch the video. Success, and we were able to machine the pocket completely using only one set of inserts. Again, let's review the tool wear, this time before and after cutting on the P20 tool steel. We can see less than 0.1 millimeter of wear after the cutting. Now for something much softer, aluminum 6061. Let's watch the video. The pocket machined in only 2 minutes, and we were able to remove 633 cubic centimeters of material. Let's look at the insert wear before and after cutting of the aluminum 6061. We see less than 0.05 millimeter of wear. Something to note is, without coolant like shown in the video, material buildup occurred on the inserts. Coolant is highly recommended for cutting aluminum. Now let's look at what development was done in SolidCAM after seeing our test cuts. Since the support of insert cutters is new, we added an option in the CAM settings to enable this feature. We created certified materials, 304 stainless steel, 316 stainless steel, aluminum 6061, and P20 steel, and have added them to the install of SolidCAM using a new material category. We also have cut additional materials that will be added later, like titanium and D2 tool steel. The new category for insert cutters requires 4 fields to be filled out in the database. In the picture, cutting angle is not shown in red, but will need to be entered in the future. These 4 fields have been filled out from our test cutting on the certified materials. The creation of a new insert material can be created by right-clicking on an already created insert material. This allows anyone to do test cutting and capture the data to be used consistently. We also created a new tool table for the certified ISCAR tool that can be imported. We have added the tool table to the install. With the certified tools selected, the certified insert materials will be shown and will be able to be selected in the iData page of the tool table. We used message field 5 with the string iMachining insert tool to enable the selection of insert material databases. If creating your own tool and material combination, adding this string is required. Once the tool is selected, you can go to the Modify Cutting Conditions tab and verify the insert material has been passed to the operation. Viewing the Cutting Conditions tab, we should be able to see the entered values from the database at level 8, as long as the machine does not have any limitations that were used to reduce the cutting conditions. Now we can calculate the toolpath. Lastly, I'd like to share a tip before finishing the presentation. To avoid problematic breakthroughs into air, it is recommended to block off these areas and use a roughing cutter to break through using an additional operation. Thanks for joining the webinar. Please feel free to email me for questions and help related to iMachining for insert tools, and also any topic related to iMachining.
Okay, Chris, thanks a lot. We do have several questions that we
Okay.
that have come up.
Sure.
And we are lucky enough to have with us also Mickey Berman, who is the scientist also of iMachining in the first place. And Mickey, I have some questions for you. Is that okay?
Yes, fine.
Okay, just one moment. Okay. Okay. Let me see if I can get the questions. The first question that I see here. Oh yeah, okay. Can I define my chosen porcupine insert cutter in the same way? And in the same tool table, I define my chosen solid carbide end mill.
Yeah, currently there is no insert porcupine style tool in the current tool table, so we just defined a regular solid carbide tool or end mill in the tool table.
Okay.
So I think that answers the question, I hope.
Okay. Okay, just a moment. Sorry, Mickey, can you add to that?
Let me try. Hello, everybody. This is Mickey. Let me just read again the question so that we are all aware of what the question was. The question was, can I define my chosen porcupine insert cutter in the same way and in the same tool table I define my chosen solid carbide end mill?
Yeah.
My answer is iMachining, we should realize, is different from all other milling cam and high-speed milling cam systems in that it calculates and proposes to the user a complete set of optimal tool paths and cutting parameters that actually work on his machine on the first attempt, using his chosen cutting tool to cut his defined workpiece out of his chosen material in a much shorter cycle time, about 70% or more shorter, with dramatically reduced tool wear and tooling cost and much less machine wear than any other CAM system. iMachining does that using proprietary knowledge-based algorithms that consider the material's characteristic behavior during a cut, the various geometric and mechanical properties of the cutting tool, and the machine's rigidity and capabilities. It considers all these things and calculates the optimal cutting speed and radial depth of cut for a planned cut of the desired axial depth. However, since the variability of the geometric and mechanical properties of porcupine indexable insert cutters and their inserts is much higher than that of solid carbide end mills, what is much higher? The variability in geometric and mechanical properties. And since metals react differently to being cut by such porcupine cutters compared to being cut by solid end mills, those algorithms had to be modified to take into consideration all those new properties and had to be recalibrated. So now, iMachining has two sets of technology wizard algorithms, each using a different set of parameters. One set for porcupine indexable insert cutters, the other set of algorithms for solid carbide end mills as before. For these reasons, we built a new tool table for porcupine indexable insert cutters. For the same reasons, we also built a new materials table. That concludes my answer.
Okay, let me see. I believe I do have another question that just came up. Oh, okay. What can I do if the material I want to cut with a porcupine indexable insert cutter using iMachining is not included in the materials that that are on the table?
In the new materials table, you mean?
That's correct.
Okay. We already certified 6 materials to be cut with porcupine indexable insert cutters and plan to add 2 more, as we saw in the webinar, in the very near future. We believe these 8 materials are those that our global customers urgently need to cut with porcupine indexable insert cutters using iMachining.
Okay. There's another question. I think it actually has to do with the previous question. What can I do if the porcupine insert cutter I want to cut, if I want to cut one of those materials using iMachining, is not included in the new tool table?
Uh-huh. Okay. We are announcing that we are setting up a service to certify an uncertified pair of material and porcupine insert cutter. A customer who needs this service will supply SolidCAM with the manufacturer's catalog data of the tool and the inserts and tell us which material he intends to machine with this cutter using iMachining. We will then run the necessary calibration process, which are actually quite a few test cuts and measurements, do the arithmetic and add the material and tool data to the relevant tables.
Okay.
Answers it.
Okay. Here's a good question. Is there any reason for my customers to use such an indexable insert cutters? They mostly use small and medium-sized machines and are very happy using iMachining with regular solid carbide end mills.
Yeah. Okay. Let's see. Generally, insert cutters, especially indexable porcupine insert cutters, when used with good cutting conditions, remove material faster than solid carbide end mills and exhibit tool life or insert life comparable with that of solid carbide end mills. For big parts, where the geometry of the workpiece warrants a large diameter cutter, for example 20 millimeter or higher, and a large cut length, for example 15 millimeter or higher, the cost of a suitable solid carbide end mill can be very expensive and can reach many hundreds and even thousands of dollars depending on size and quality. On the other hand, suitable inserts can cost $3 to $15 each.
Wow.
Only. This means that in the aerospace and automotive industries, plants that make large parts often prefer to use insert cutters. This is true also for some machine builders, shipbuilders, and repair shops for large parts. Some machinists believe that high-speed machining is not suitable for their big machines, which they think are too slow for it. This is often not true. Depending on the material, in most cases, the required spindle speed is not higher than 1,000 or 2,000 RPM. Remember, we're talking about large diameter cutter. Conversely, there are insert cutters of small diameters, 10 to 16 millimeters, with quite large cut lengths, which, depending on the case, can be more economical to use than solid carbide end mills.
By the way, I think it's very. I do remember also from the days when I was working in the machine shop, and we had these large end mills, and I know they were very, very expensive, and like you said, the inserts are much cheaper. So I think the cost is a major issue. A very good point, Mickey.
And also the fact that they can remove material faster.
Exactly. Okay, I have one more question for now. Okay. If my local tool supplier, okay, I have a regular tool supplier, has an insert cutter, which say that it seems equivalent to the imported certified insert cutter in the tool table recommended for my job, can I use that one instead?
And this would need to be carefully checked by your local SolidCAM support engineer to make sure the local tool is indeed exactly equivalent for the job at hand. Sometimes a slightly different rake angle, for example, on your inserts can mean that using the cutting conditions recommended by the iMachining wizard for the imported tool could cause harmful chatter when used with the local tool. If that tool is needed for a long production run and the price difference is significant, your best course of action is to use SolidCAM's certification service, which would result in that local tool being added to the new table after being calibrated and certified.
Excellent. Okay, that is basically it for now. There are some more questions, but those questions will be answered later on. We have all the questions written down. We will get the emails out later on for those questions. Again, Chris and Mickey, thank you very much for the webinar. And this webinar has been recorded and will be available later on for everyone to view. So everyone take care and have a great weekend. Bye-bye, everyone.
Bye-bye.